Hi guys, I want to talk about how to master edema. How to master edema. One question, what is edema? We say that edema is the excessive amount of fluid in the body tissues. Extra vascularly. It is the excessive amount of fluid in the body tissues extravascularly. To mean that when we say excessive amount of fluid intravascularly, that one we don't consider it as edema. Or when you give your definition, that amount of fluid in the interstitial space, I will say that also you are not right. Or maybe when you say amount of fluid in the extravascular space, still I will say you are not right. What we need to be specific on is the excessive amount of fluid in the body tissues extravascularly. Extravascularly, that one we mean that it is not in the intracellular space. So let us have a simple diagram of our tissue to explain it a bit clear to you. I want to explain it a bit to be very, very clear. Let us say this is our tissue. This is the tissue. This is the tissue. This is maybe our left heart. This is our left heart. And this is the arterial system. This is the arterial system. And from the arterial, we have the meta-arterial and then the microcirculation, which are the capillaries. And then we have the venous end, which now they drain or blood into the right side of the heart, and then taking it through the pulmonary system into the lungs for purification, and then back or into the left side of the heart by the pulmonary vein. So here in the lungs also we have the microcirculation. So this one is the microcirculation, this is our tissue, and then let us assume that this is our body cavity. This is our body cavity, and then maybe these are the parenchymal functional cells. So to say this, this one the microcirculation, these are the parenchymal cells, meaning that the space here is the interstitial space. Let us have a beautiful human being here who is maybe 72 kg. To get total body water, it's always total body weight. Total body weight is always lean body mass and total body water. And total body water, this one means both intracellular and extracellular. So to say lean body mass is always 40% of total body weight, and then total body water is always 60% of total body weight. To assume that this person is 72 kg, 60% total body water is going to be around 42 liters. That one we say 60 over 100 times 72. We're going to get about 42 liters there. So 42 liters total body water. We say that total body water, we have intracellular or intracellular, and then extracellular. Intracellular is always 2/3 of this, of total body water, which is 42%, and the extracellular is only 1/3 of 42%. So, to mean that amount of fluid in the intracellular is 2/3 and the extracellular is 1/3. That one to calculate, we are trying to get normal amount of fluid in different body compartments. In different body compartments. Body compartments, here we have the plasma, we have the interstitium, and then we have the intracellular. So here we say the intracellular, if we calculate this, it's going to be around 28. So we say the intracellular we have 28 liters of water. To mean that in the interstitium space, we remain with the 14 liters. And the 14 liters, we assume that 3.5 liters in the microcirculation and the 10.5 in the interstitium. We make it very clear to that. That one is to normal circumstances. Now let us assume that this fluid here in the interstitium space is around maybe 20 liters. In the interstitium space, it has doubled this to 20 liters. That's what we say edema. Edema. In this case, fluid normally occur. Edema, to make it in simple definition, there is a type of pressure called the hydrostatic pressure, which is normally generated by the heart pump. When this pressure is high, let us say it's 35 millimeter of mercury. That's the hydrostatic pressure. When the pressure is high, there will be a lot of fluid shifting through this capillary membrane, shifting into the interstitium. And remember, this amount of fluid normally being sucked by the type of plasma protein. Maybe to remind you of plasma protein, we have fibrinogen, and again we have globin, and we have albumin. So here we talk classically the albumin that normally sucks this water so that we don't get excess fluid in the interstitial space. But due to some reasons, due to pathological conditions, we can have edema, maybe a point when the albumin is very low. Yes, and these albumins would determine the level of the oncotic pressure. So, to talk of edema when there is excessive amount of fluid here. And how will you define it when there is excessive blood in the microcirculation? Maybe some will say vascular engorgement, but here to mean when there is increased input and there is reduced output in the venous end, there will be hyperemesis. Hyperemesis and the congestion. Congestion here means that there is reduced output and then there is increased input. So that is hyperemesis. When you talk of maybe the vascular engorgement, you talk of both congestion and the hyperemesis. For example, maybe this is the phalange. This is the phalange, and maybe there is vascular engorgement, or maybe there is a swelling of this tissue. When it is swollen, to say that there is increased pressure, increased input, and reduced output, that will make it appear reddish erythematous. So that one we call hyperemesis and congestional vascular engorgement. So the term to use is hyperemesis and congestion. And let us say maybe there is intracellular edema. Moment there is intracellular edema, first I would like maybe to remind us on reasons that can lead to intracellular edema. Number one of reasons that can lead to intracellular edema may be when there is ischemia. Ischemia, that one in short term, it means there is cut of blood supply and increased oxygen demand. And remember, the cell has a pump, type of a special pump called sodium potassium ATPase. Sodium potassium ATPase, this mechanism, this machine works when there is enough oxygen supply, enough blood supply that help to transport nutrients, the amino acids, and other components that will help regulate this mechanism. So, for example, let us say that to have a cellular edema means there will be ischemia. Cell will be hypoxic, and when the cell is hypoxic, the membrane will be permeable to this type of component mineral called sodium. Sodium is commonly in the interstitial space, and the potassium is in the intracellular. So actually, we do say that the intracellular is a bag of potassium. The cell is a bag of potassium, and sodium is always out. Sodium is always out. We define it as in terms of a man is allowed to go into every gate or every, but does not allowed to enter into any house, into every house. So that is sodium. So when there is intercellular, when there is an hypoxia or maybe ischemia, there will be increased permeability that will lead to influx of sodium into the cell. And that means the sodium potassium ATPase, this mechanism is interfered with. Therefore, it's not able to pull sodium out. The sodium will get in. And remember, sodium is bound to a lot of water. So a lot of water will be pulled into the cell. That one we call hyperosmolarity. Hyperosmolarity. When there is intercellular edema, meaning there is excessive amount of sodium into the cell. Are we together? So, to make it clear, we are talking of the intracellular. When also there is edema in the body cavity, specifically we talk of the serous body cavity. Serous body cavity. For example, maybe we talk of when there is fluid in the pleural space, which we say maybe pleural effusion or hydrothorax. In the peritoneum, we can say ascites or hydroperitoneum. And maybe when there is fluid, excess amount of fluid in the pericardial space, we say maybe hydropericardium or pericardial effusion. So to make this definition more clear, we'll say excessive amount of fluid in the body tissues extravascularly and or serous body cavity. Serous body cavity. This is generally the term. What we usually know that to the medical students who define edema, they just say excessive amount of fluid in the body tissues, maybe in the interstitial space, which is not wrong, but this is now the complete term of edema. Are we together? So we are going to talk about the extracellular space. We have extracellular, we have the interstitial fluid, and then we have the intravascular extravascular, which we say the plasma. Which we say the plasma. So there's amount of fluid in the plasma, which we say the extracellular, and then the interstitial space. So our next our next explanation to edema, we're going to talk about the mechanism under which edema can occur, causes of edema. It's our next lesson. Thank you.